Assalamu alaikum students. Article for today is cyclotron. Now what is basically cyclotron is? Cyclotron is again a device that is used to get the high velocity, or you can say the high energy charge particles, right? Again, this is the application of magnetic force, and how it is going to be the proceed we will surely discuss now. Now to consider the fact, we understand the phenomena that wherever there is a um, electric field provided, suppose this is the positive charge particle, positive charge plate, and this is the negative charge plate. Now if I place an electron over this point, or you can say if I placed an electron in this at this particular point, what is going to happen? If this is suppose this is a positively charged particle, so this positively charged particle will definitely move towards the negative plate, away from the positive plate, right? So this is the velocity of this particular charged particle having charge q. So in this condition, the force which is experienced by this charged particle would be equal to F equals to QE, that is the electrostatic force. And because of this force, it is accelerating in the forward direction. So according to Newton's law, acceleration would be equal to F divided by m, right? And putting the value of this F, what we are going to get, we are getting QE divided by m. Now this acceleration is basically equal to QE divided by m, and the velocity of this electron, acceleration of this electron, right? Now we know that the velocity of this was the final velocity. Initially, definitely, this charged particle was at rest. So the final velocity, which is equal to v, is going to be the velocity. So I'm going to write it like this using the second equation of motion, which is going to be Vf equals to Vi plus At, right? So V is equal to 80 since Vi equals to 0. In this condition, if I'm going to put the value of A, this value, so V is equal to QE divided by M multiplied by T. So that's how velocity can be calculated. I'm naming this equation as equation A, right? Now moving towards the next step. Since cyclotron is a device used to get the greater velocity of electron, so if I want to increase the velocity of the electron, what I need to do? I need to increase this T, right? Definitely Q and M are constant. This is the specific charge, and we are having E would definitely be constant. So if I want to calculate keeping E constant, if I want to change get the higher velocity, I want a greater time period. So what would I do? I would definitely increase the distance between the charge plates, right? This is the positive charge plate, this is the negative charge plate, and if I'm increasing this distance between them, which was initially less, definitely you can see from this state what is going to happen. Like if I'm assigning the name as D1 and this is now D2, right? So we can clearly see that D2 is greater than D1. So in this situation, what is going to happen, that the time period will be greater, right? So the greater time period will be observed. So if initially the value of T were here was T1, so here the time would definitely be T2. Likewise, if the time here is D2, I can write the situation, I can write T2 is greater than T1, right? To get this condition, I notice that if I'm increasing the value of T, the value of E decreases. Why? Because E depends upon the distance between the plates directly. If I'm increasing, sorry, indirectly. So if I'm increasing the value of distance between the plates, what is going to happen? E will decrease. T would definitely increase, but in this case E would decrease. Now if E decreases, we are not going to get the velocity to be greater, so we should increase E, right? Since by the relation, by the formula of potential gradient, E equals to V divided by R. From this relationship, we can conclude that the value of V equals to ED, basically V equals to ED. So this so here V is the potential, and R is the distance between distance, and E is the electric field intensity. So they are having an inverse relationship. So according to the formula which I am going to write, at this point E1 is equal to V divided by D1, and in this condition what is going to happen, I can write E2 equals to V divided by D2. So we see that if we are increasing the value of D in this figure, E2 would definitely decrease, right? So we can say that E2 is smaller than E1, right? So this is the main thing which is observed. If I'm going to increase, if I'm going to get a greater time, if I'm accelerating that charged particle for a greater time. So to increase E, what I'm going to do, to increase E, I'm going to do this thing, that I'm going to decrease this particular distance between the charged particles. Now we can see that I have decreased the value. Now if I've decreased the value, that is the decrease the distance between the charge plates, what is going to happen, I have decreased E, that means E has increased. So in this condition I can write E will definitely increase in this situation, but time experienced by that charge particle would decrease, right? So in this condition, again velocity cannot be increased, right? So what we are going to do, so I've drawn a figure, a clear, much clearer figure, and combined figure as well. So there is a distance d1 which is the smaller one, and there is a distance d2 which is the greater distance. I'm going to do explain for both of them. If d1 is like d1 is smaller, if I've put the charge plate close to the other plate, if I've decreased this distance, I've put the negative charge plate at this particular point, what is going to happen, d1 will definitely is less. If the value of d1 is less, then according to this inverse relationship, e1 is definitely going to increase. And because of the relation x equals to vt, what is going to happen, the value of t will also decrease. In the second situation, what is going to happen, if I'm going to put this plate at this particular point, negative plate has been replaced at a far distance. The now the new distance is d2. If the value of d2 is greater now, so according to this relation, if d2 is greater, that means t is greater, there is more time achieved, but the value of e has been decreased. So in this situation, we are not going to get v to be very greater, right? But I need to achieve velocity to be greater. So to what should we do in this situation? We are going to do one simple thing. I will draw the diagram. So as you can see in this figure, if I'm having a charged particle like at this point, a positive charge particle, then what is going to happen, this charge particle will definitely move towards the negative plate, and when it moves towards the negative plate, what is going to happen, so consider initially the velocity of this charge particle was 0, and after it is moving towards the negative plate, definitely its velocity is increasing. And consider that after reaching this particular negative plate, its value of velocity gets v. Now consider there is another charged particle. If it is moving from the velocity v, and if it accelerates in this particular electric field, after some time its velocity becomes 2v. And consider there is another charged particle whose velocity was initially 2v. So after accelerating in this electric field, its velocity is going to be increased, and consider this velocity to be 3v. Now consider that this particular in this particular field there are so more charges, more and more charges, again and again charges are moving. So consider that the final velocity we achieve for the electron is going to be 1000 v equals to 1000 v. Then imagine what sort of kinetic energy we are going to get for this 1000 volt 1000 times velocity of that particle. It is going to be a very big value, right? So if I really want to get a high energy or high velocity particles, what I am going to do, we will definitely going to do this thing, that as this charged particle is moving forward in this particular direction, if I in any means, by any means, if I am able to introduce this charged particle on this particular point, like at this particular point, if I really can enter the charged particle back into the field, like again back into this particular field, so then its velocity was initially v, and then by increasing its velocity, as it is getting higher and higher, it is getting 2v velocity. Now if I use the same 2v velocity electron or the charged particle, or any particle, what is going to happen, if it is again introduced in the same electric field, its velocity would become 3 volts. Now if again I introduce this 3 volt 3 times of velocity of the charged particles again into this electric field, what is going to happen, the velocity would increase to the 4v. If I again introduce this particular charged particle in this field, what is going to happen, its velocity would increase and we get 5v. Then 5v would become 6v if again introduced. So basically what we want, we actually want to bring this charged particle again and again into this electric field. What is going to happen if I am introducing this charged particle again and again in electric field, its velocity is increasing, as you can see from this figure, right? So how can we bring the charged particle again and again into this electric field? So to get this particular stuff, now we require the magnetic field. Basically magnetic force would result in moving that charged particle at this particular point back into the magnetic field. Like why? Because of the magnetic field we are going to get a curved path. Like suppose if the charged particle is at this point, then after if I provide a magnetic field on this particular point, what is going to happen, that all of the charged particles, okay, so if I apply the magnetic field other in this situation, like this is the provided electric field, this is the electric field region, and this is the magnetic field region, right? So if I apply magnetic field in this region, when electron or the charged particle has reached at this particular plate, what is going to happen, that the path of that charged particle will start to bend, like it would be like in this condition, and again it will enter in this particular electric field, right, in this way, and again there was, so we can see this charged particle is moving towards the next plate, that is the positive one, and in this positive plate what is going to happen, I'm again going to provide magnetic field in this region. So what is going to happen, that the path of this particular charge particle is again going to be the curved one. So basically what we are doing, we are introducing this charge particle again and again into this electric field is basically going to increase the velocity of that charge particle, and b, that is the magnetic force, is responsible to move that charge particle back into the electric field, because it curves the path of the charge particle. So that's how we are again and again going to get the charge particle back into the electric field to increase its velocity, right? So this is the principle on which this cyclotron works, in which E basically accelerates the charge particles to increase V, and the magnetic field, what it is doing, it will re-enter the charge particles into the electric field. So both electric and magnetic field is going to work over in this particular device, which is known as the cyclotron. Now the device itself, how we can draw it. So to draw that device, I am going to see. So this is basically the actual figure of cyclotron, right? Not the actual figure. This is basically a visual representation of cyclotron, in which you can see that there are basically two D's. Like, what is D? If you are having a circular path, like a circle, like consider there is a disk you are having. If you divide that disk into two equal parts, right, what is going to happen? We are going to get two D's like this. Okay, so this is D1 and this is D2. So we are having now two D's as indicated, as you can see here in the orange color and here in the blue color, or in this figure again we are having D1 and here it is D2. So in this figure you can see that between these D's we are having an electric field. Like, suppose we are having an electric field in any direction, like if I consider this direction, the field is going to be from this point to this point. Likewise, that means we are having a positive plate is right here and a negative plate is in this in on this side, right? um, so direction of electric field is towards the left side. um, as you can see that there is a little thing which is placed in this central point. This, what is this? This is basically an ion source, right? In the center of these two D's we basically place the ion source. What ion source do? Ion source is basically a heater, right? And when it heats up, it generates the ions, right? So this is known as the ion source, represented by S. Like, if I want to draw S, I can, like, here the S would be in this point. So this is S in the green color, right? You can see this. So this is S, that is the source. Now coming towards the fact, so I have drawn another figure. In this figure you can see that we are having the two D's and a magnetic field has been supplied to it, and these two D's are connected to an external source. The source must be an alternating source. So this is known as alternating source oscillator, or you can simply call it oscillator. And since this is an alternating source, so what is going to happen? Then the polarity will definitely be changed after the every half cycle. So what use is going to be we are having because of this oscillator, I'm going to explain it later. But firstly, consider the fact that this oscillator is going to have a very very high voltage, that is approximately 10 raised to power 4 volts, and the frequency it is going to have is definitely going to be definitely very high, that is 10 raised to power 6 hertz, right? What does this mean? I will explain that later after you perform this whole experiment. So in this configuration, what is going to happen for the first half, we are going to have this particular plate to be positive, right, and the other plate would be negative. But for the second half, what is going to happen, this plate would become negative and the other plate would become positive. So this polarity will change according to this situation. Okay, so consider that we are having a positive charge particle right at this point, and this charge particle will move away from the positive plate and move towards the negative plate. During this movement, its velocity is going to be increased, right? Now what is going to happen, the velocity of this particular like wait, I need to draw it a little bit lower. Yes, so I have drawn it a little lower. What is going to happen, that from zero velocity, the charged particle, which is positively charged particle, it will move in the forward direction under the influence of electric field and reach to the other point of the d, towards the negative plate. Now what is going to happen over here, that its velocity has increased, and consider that velocity is now to be v. Now it will definitely, this electron will definitely enter into the d. This, when this charged particles enters the d, what is going to happen, it will experience the um, magnetic force, and okay, so it will experience a magnetic force and its linear path will be now be curved, and it will again enter into the electric field, right? Now as it moves in this electric field, its path would be like this. It will move forward in this particular point, right? And this is going to be happen, you must be wondering that why it is not moving in this particular direction, that we can draw it in this direction. Why it is not going to happen? It's because of the Fleming's left hand rule. Because magnetic force, how it is experiences, since the direction of b is towards the negative z, and the direction of velocity is in the x-axis direction, so the direction of force, that is the magnetic force, would be in the like it would be in the upward direction. So that's why this particular charged particle, positively charged particle, will have a motion in the upward direction, and again its path will be curved, and that's how it will again enter into the magnetic field with velocity v, right? In the d, there is no electric field, so its velocity won't be increased. As it will move in the forward direction, it will experience the electrostatic force. Because of that, its velocity is increased, and when it reach the other part of the d, its velocity, consider its velocity has now become 2v. Okay, so at 2v, what is going to happen, the charged particle would again entering into the d, so there will be no electric field, only a magnetic field is there. So the path of this charge particle would now be greater. Why? Because now the velocity is greater, so definitely the radius would also be greater. So what is going to happen, it is going to have a greater radius this time, and it will again ready to enter at the velocity of 2v back into the electric field. So when it enters again into this electric field, its velocity will increase and it reaches the other part of the d at a velocity of, consider, 3v, right? And again what is going to happen, since its velocity has increased, so its radius will also increase. So with the greater radius, it enters this particular electric field again with a velocity of 3v. So again when it enters this electric field, its velocity is going to increase again and it will reach, suppose at this particular point, with a velocity of, suppose the value of this velocity is 4v, um, and again, because it is having a greater velocity, so its radius is now also greater. It enters the field at electric field at this particular velocity of 4v. Again it enters the electric field, its velocity is again increasing. So consider at this particular point its velocity is 5 volts, so it again enters into the, achieving a higher radius because of greater velocity. Again at this point its velocity is 5 volts, it's going to enter the electric field again, and velocity would definitely increase. Consider this velocity to be 6 volts, right? Velocity greater, definitely radius would also be greater. It again enters into the electric field at a velocity of 6v, and when it reaches to the other part of the d, its velocity has been increased. Consider it to be 7v, and again and then again and again. That's how we can increase the velocity of electrons up to thousands of thousand times of the initial velocity. So how this is going to be increased, because of the electric field, right? Electric field increases the velocity, and magnetic field is basically putting back this charged particle again into the electric field. Now consider that at the final point, the velocity has been increased so much to our desired value. What is going to happen? So what is going, suppose I want the particle to be received at the velocity of 7v. 7v is also a very small value. I want to be received it as, suppose, at the value of 1000v. So when I receive, how can I receive that particular charge particle? What is going to happen, that there would be a small window at this particular point, right? There is a window, and through this window there is a target, right? There is a target at which these charged particles are going to hit. So these ions will definitely, they will move towards this particular source, and they will definitely move out of that window and reach to this particular target, right? And that's how we can receive all the charged particles with a greater velocity in this way. Now consider that all the electrons, sorry, all of the charged particles are having a cyclotron motion, right? So you must be wondering, what is the purpose of having this oscillator, that the polarity is going to be reversed? What is the purpose of that? So to get the purpose, I am going to describe it in this way. To understand that thing, consider that the charged particle is moving from the positive plate um, to the negative one, right? In the positive x-axis direction towards the right side. Now if it is moving from this point to that point, and when it enters again into that particular field, now in this condition, if the charge plates are in the same way, then that charge particle, which is basically the positive charge particle, it will be like, suppose if it at this point, so this charge particle has to do, this charge particle, it has to do work, since it is having a positive charge, so, and this is it is on the negative plate, so it has to do a lot of work to move opposite to the electric field, since the direction of electric field is in this, yeah, like towards the right side. So this charged particle, that is the positively charged particle, has to do a lot of work to move away from the negative plate and moving towards the positive plate. So this will definitely reduce the velocity. Now if the velocity is getting reduced, then how we can get the velocity to be greater? So every time the charged particle will turn back, its velocity would decrease. In this case, why? Because if at this particular point, right, if the charged particle reaches after getting a lower velocity, its velocity has been decreased, and it reaches at this particular point. When it reaches at this particular point, it will again enter into the magnetic electric field, and moving towards, like, moving in this particular direction, its velocity would increase. Reaching at this particular point, its velocity has been increased, but again, when it again enter into the circuit, its velocity is going to be decreased, right? When it definitely, when it reaches at this particular point, its velocity is again going to decrease. So velocity is increasing and then it is decreasing. Then how we are going to get the increased velocity? So to avoid this, we have to synchronize V and E, right? And how this synchronization will occur, to understand that thing, you should keep this thing in mind, that we have to calculate the time period for the charged particle, and then set the oscillator to change the polarity after that time period. So in this case, what is going to happen? All the charged particle will definitely move towards this side, right? To get the synchronization effect, we to get V and E to be synchronized, what we are going to do, we are going to calculate the value for the time period. So to understand that thing, the charged particle will move into the electric field, and after reaching the other side of the D, it will be having a curved path, and it will again re-enter this particular electric field. To avoid the decrease in velocity in this situation, what we do, we basically change the polarity of the oscillator. If the polarity of the oscillator is changed in this situation, what is going to happen, that now for the second case, when it is moving back into this electric field, when it is moving back into this electric field, what is going to happen, this plate would become positive and this plate would become negative, right? When this plate becomes positive, definitely the positive charge is there, so positive charge will move away from the plate, and it will reach to the other side of the D. In this condition, it does not have to do any kind of work, so velocity would definitely increase, right? Now again, what is going to happen at this particular point, the polarity would again reverse, and when the polarity reverses, this is going to be the positive plate, right? This plate would now be the positive plate, and the other plate would be the considered as negative plate. So the direction of charge particle would be like this. There would be no there would be no requirement of doing the work done, right? Again, when it is going to enter this particular electric field, what is going to happen, this fact would be done by changing the polarities, and when the polarities are changed, it will come back into this particular electric field in this condition. So all the lines which I have drawn orange for this kind of case, what is going to happen, the polarity is would be the change one, and all the green lines show that the polarity is from, like, electric field is from left to right, right? And for the orange lines case, we are having that the polarity is from right to left. Now this condition can be achieved, but we have to make sure that the time which a charged particle is taking at this region in the D should be equal to the time when the polarity is going to reverse, right? So the time taken by this time which is taken by the charged particle in the D to get a curve and then again get to enter in the electric field, this time should be equal to the time which is taken by the battery to uh, reverse its polarity, right? So t and t prime should be equal. And how we can do this, how we can determine the value of this t, how can we determine the value of this t? We will definitely do a simple um, calculation which we have already done. um, we already knew all these equations which I have written over here. We already know that V is equal to QRB, as we have calculated earlier in the previous lecture, and omega, the value of omega to be QB by M, the value of T, the value of F, the value of R, and the value of kinetic energy as well. And we know this thing that V and R are directly proportional. So other things like omega, T, and frequency, they are not depending upon the radius. Kinetic energy is also depending upon velocity, or you can say the radius, right? So this time period which we have calculated, this is basically the t, right? The t which I was talking about, this t. So this is the value of t, that is 2 pi m divided by qb. From here we can calculate the value of time period, right? How much time required by this charged particle to having a curved path. So this time period would be equal to, obviously m is known because of the charge particle is known, charge of that, magnitude of charge of that particle is known, B supplied is also known, so we can easily calculate the time period. Suppose the value of this time period comes out to be, suppose it is 20 millisecond, right? Suppose this is 20 millisecond. So if this is 20 millisecond, I will set my oscillator time to be 20 millisecond. What is going to happen during that duration, during the 20 milliseconds? What is going to happen, that all the charged particle is will start movement from here to this point, and meanwhile when it starts moving from this point to this point, so starting from here to here, the time was 20 millisecond. So during that duration, after every 20 milliseconds, what is going to happen, that the oscillator will repeat, or you can say will change its polarity. After 20 milliseconds, what is going to happen, that the charged particle will be at this particular point, right? And then again at 20 millimeter 20 milliseconds, what is going to happen, it will again enter into this particular electric field. Then that's how we are going to synchronize E and V with the help of the time period, right? So this is the main thing, and you must be wondering that if you are increasing the velocity, and hence the radius is increasing, then definitely the time period should increase. But as you can see in the formula, the time period is not depending upon the radius. So for every radius, so for, you can say, for the whole cyclotron movement of the charged particle, time period will remain same. So time period will remain same. So ultimately what we see, that we are going to get increased velocity at every step when that charged particle is going to enter into the D, right? So I hope it is clear up till now. And this kind of synchronization in which E and V are in step, this is known as in step synchronization, because E and V, they are in the same direction every time, right? So now moving towards the limitations of the cyclotron. Now coming towards the limitations, the first limitation of cyclotron is that neutrons, for the neutrons, the cyclotron is not going to work, right? Why? Because cyclotron only accelerates the charged particles, right? If there is no charge, it won't definitely accelerate in the electric field. So the first limitation is that if q equals to 0, then definitely fe would be equal to 0, right? And fb is also be equal to 0. So it is not going to work for the neutral particles, right? Number 2 is that I have we come to know at the question that how much velocity can we increase. Like if velocity is increasing continuously, like from v to 2v, then 2v to 3v, and up to 1000 value it can go. What is the last limit to which we can increase the velocity? Can it be equal to the speed of light? Is it possible? No, it's not possible, right? Why it is not possible? Because we have put our effort in putting E and V to be synchronized, to be remain in step. But as the velocity is getting higher, that consider that velocity has become 90% of the speed of light or 80% of the speed of light, what is going to happen? That at higher velocity, when V increases, like if v is going to be increased, the relativistic mass is going to be increased, right? And when the relativistic mass increases, time period also increases, right? These relativistic effects you will definitely going to learn in chapters ahead. Okay, so because of the relativistic effects, what is going to happen, that if we are increasing the value of v, like suppose we are moving it to 90% of the speed of light, or 70% of the speed of light, or 80% of the speed of light. So if I'm increasing the value of v, relativistic effects will definitely come into action. And these relativistic effects you're going to learn in chapter called modern physics. Giving you a short a chunk of review of that. These are the formulas for relativistic mass and relativistic time. So you can see in these formulas that if you are going to increase the value of v, what is going to happen? Overall, the value of this mass would increase, right? This relativistic mass is going to be increased. And if you increase the value of v square over here, taking the square and then increasing that value, then 1 minus that increased answer, and taking the under root, this will reduce the value, and ultimately what is going to happen, this t would also increase. So if t is going to be increased, which we earlier had mentioned that this time period remains constant throughout the cyclotron movement, now the t will definitely increase at higher speed. Now at higher speeds, if t is increased, E and V won't be longer in step, they will get out of step, and that's how the velocity restarts and no further acceleration would occur. So we can receive the velocity to a fixed value, and after that value there will be no further acceleration, right? Now the third limitation is that it is not applicable on electrons, right? Not applicable on electrons. So we cannot introduce electrons in cyclotron. Why? Because the mass of electron is very very less as compared to the positive particle, that is consider a proton or any like hydrogen ion or the helium ion and so on. Electrons are having a very less mass, right? Very less mass, which is going to be the value of the order of minus 31. So in this case, what is going to happen? With this less mass, velocity is going to be increased so much, right? So these higher velocities are unable to be taken in, like we cannot record those values, we cannot achieve those values, because it gets a higher velocity value in a very small interval of time, and nothing is going to be happen. So we cannot introduce these electrons in the cyclotron, right? Next thing, that the fourth limitation and the last one is that the higher the positively charged particles with larger mass, right? So we can write that the heavier positively charged atoms, like their ions, definitely, these are also cannot be introduced in cyclotron. Reason behind is they are having a large mass, and when the mass is large, velocity would definitely increase. But when the velocity has reached to near to the comparable to the speed of light, what is going to happen? Time period will increase. When time period will increase, ultimately what is going to happen, that E and V will no longer be in synchronized. They will get out of step, and ultimately the velocity gets reduced. So for the heavier positive atoms, we cannot use the cyclotron effect, right? So because of these limitations, cyclotrons are in less usage. As a particle accelerator, we use to accelerate the particles, we use other devices or other machines which can provide us the accelerator for the heavier positively charged atoms and for the electrons as well. Coming towards the uses and applications. Okay, so what is the first use? Um, this basically can be used as definitely as a particle accelerator, right? So we can use it to accelerate the particles which are light in mass, having a smaller mass. So it is used as a particle accelerator. It is used in many experiments which are performed in nuclear physics and particle physics as well. And what are the practical applications? One of the application is the particle accelerator, and the other application which we observe in medical field is basically that particle therapy is used to treat the cancer. And there is also another technique, we are having the particle therapy to treat cancer, and a proton therapy in which these particle cyclotrons are used, right? Proton therapy as well. Both of these are used to diagnose the cancer cells, right? Any blockage in the system, like in the circulatory system, and to treat the cancer as well. Like to treat the cancer means definitely to destroy the cancerous cells. And again, in many of the experiments that are performed in nuclear and the particle physics, right? So that was the article for today. It is not given in your book in so much detail, so I provided in your detail as this is going to help you in your entry test as well. Thank you so much for today's article. Allah Hafiz.